So we started working together in 2014, building the SD Core solution. And this consists of the forwarding plane or the switches from Noviflow and the controller and applications from Lumina Networks.
And in the space of 6 months, we developed the solution, we tested it, and it was deployed into a live production network carrying real traffic. And so that then enabled the carrier to actually take advantage of a much lower cost solution than your traditional routed-based network, with all of the benefits of software, so being able to be provisioned in real time and operated in that way. But going on from that, they actually found that they got a huge benefit from their operational teams, being able to manage this infrastructure in new ways with skills they had to develop and with new tools. I think one of the big things about 5G that's going to require a lot of focus as people invest in these networks is the actual transport network. And now the transport network is going to be critical, and one of the advances in this area is network slicing. And so by having the software-based solution, what we're able to do is actually take a physical network and to split it up into individual slices. And these slices can be each managed independently. So critical features like isolation between the slices, so that one cannot affect the other. They could even have different failover characteristics and can be managed for different applications is going to be important for 5G, because one slice might be used for an IoT application like a soft drinks machine communicating back to a head-end server. Another might be used for autonomous vehicles, and then another again might be used for consumer handsets. So you can really understand the differences in the requirements for the network there. People have huge investments in traditional infrastructure, and those investments need to continue to be leveraged. So I think what you'll see is people will start to have to refresh certain parts of their network, but not all of their network. A very common example could be certain metro or regional areas may have infrastructure that reaches end of life, and carriers will typically update those one at a time. And so what you'll tend to have is this environment now which we call multi-domain, where you could have one domain which is based off of a new infrastructure like Noviflow, and you'll have other geographic regions which are still based off the traditional. And being able to use the Lumina SDN controller to actually sit across both of those domains and stitch services together in a multi-domain fashion is really going to allow people to look at more use cases and more opportunities to be able to roll out the new technology.
Hello and welcome to a demonstration of intent-based networking by Lumina Networks. For this demonstration, I'll be using the Lumina SDN controller, which is powered by OpenDaylight, and Lumina SD Core application running on top of it. The idea behind intent-based network is that we can define a service and implement that service on the network without having to worry about all the underlying infrastructure. In addition, we can maintain the integrity of the service even if there is a change or failure in the network. This allows evolution of the network to newer technologies such as segment routing, white boxes, or NFV without disrupting services. To start, this is the topology of the network that I have set up in the GNS3 simulator. The network consists of a routed network configured for MPLS and a white box switch network which is managed using OpenFlow. The devices in this network are connected to the Lumina SDN controller. Here I am launching the Lumina SD Core application. All the functionality that you see here is also available via the API and via the OpenDaylight controller. This is the network topology view. Here you see the global network topology as well as the individual domain topologies learned using BGP link state and OpenFlow. Controller uses these protocols in addition to PCEP and netconf to discover the topologies and control different types of devices. Here we see node and port details for different types of devices in the same view, even when these devices are all controlled by different protocols. Currently, we do not have any label switch paths set up, nor do we have any paths set up over the white box switches. Right now, I have 2 of the 3 label edge routers mounted via netconf. To complete the setup, I will mount the third LER to the Lumina controller as well. Now you can see that it is successfully mounted. Now that we have the network set up and Lumina software running, we will perform some simple traffic engineering and provision a protocol independent path. This is the key idea of intent-based networking and Lumina's SD core software, that I can create network paths independently from the infrastructure. So to create the path, I will launch the create path widget, select the 2 endpoints, LER3 and OpenFlow 5 in this case, and also specify few waypoints. If I wanted, I could also have the path computation engine calculate and use the shortest path between the path endpoints. But in this case, I wanted to engineer specific waypoints for the path to use. Now that I have created a path, I can go to the topology view and we can see the engineered path traversing both the routed domain and the OpenFlow domain simultaneously. Let's go to the PCEP devices and we can see that each of the path ingress and egress label edge routers have one label switch path each. These LSPs were created by controller using PCEP protocol and signaled in the MPLS network through RSVP-TE. Here we can see details of the MPLS traffic engineering tunnels on the label edge routers, including the explicit hops that the LSP is using. Now the same path continues on to traverse the white box network, and required OpenFlow group and flow programming is done on it to realize the path. So we have established a single path over both MPLS and OpenFlow domains simultaneously. Now we are going to assign an actual network service to the multi-domain path. For this, I will create a Pseudowire, which is a virtual point-to-point connection between Ethernet segments at site A and site B. So at first, you see that I do not have connectivity between the two sites and that the traffic fails to flow. Now I am going to set up monitoring and displays, including the controller log, so that you can see how the provisioning is happening. Now I will go back to the Lumina SD Core Application Services tab, and using the paths that we had previously created, I am going to create a Pseudowire service instance. Endpoint 1 port and endpoint 2 port are the ports in the routed and OpenFlow domains respectively that are attached to the segments that we want to interconnect. Controller log shows that netconf was used to provision the service on MPLS devices. Similarly, we can see groups and flows being created on OpenFlow devices. Packets are now successfully passing over the Pseudowire service using the paths that we had set up over MPLS and OpenFlow domains. For intent-based networking to work, failure resiliency is important so that the intended service is maintained in case of a failure. To show that here, let's purposefully fail a link that supports the service path. In this example, that will be the interdomain link between LER1 and OpenFlow 1. Before the link is failed, traffic is flowing properly as expected. Once the link is dropped, traffic gets interrupted. In the controller log, we can see some messages that the application has detected the failure and is responding to it. If we look at the global topology, we can see that the dropped link is now missing. However, we can see here now that the traffic has resumed. So the application detected the failure, selected an alternate path and provisioned it into the network. The new path can be visualized in the global topology view. We can see that it avoids the failed link but still uses the waypoints that we had specified. In summary, intent-based networking allows us to define a service and automate the deployment and resiliency of that service regardless of the underlying infrastructure. Today, we were able to use Lumina's SD Core software running with OpenDaylight to deploy a multi-domain path and service over MPLS and OpenFlow simultaneously. If you would like to know more about how Lumina SD Core and OpenDaylight can help automate your network, please contact us at luminanetworks.com. Thank you.